students, today we have to do the experiment sonometer, and the aim of this experiment is to study the transverse waves over the sonometer wires and hence to determine their velocity and mass per unit length. Apparatus required: sonometer wires of different materials. Here we are using three different materials. This is the constant one, this is the brass one, and this is the copper one. So copper, constant and brass, three different materials we are using in the sonometer. This one step down transformer, horseshoe magnet, weights and connection wires. Theory: a wire carrying an electric current is placed in a magnetic field acting normally to the direction of the current. This wire experiences a force perpendicular to the direction of the magnetic field and current. For a particular length of the wire, it is thrown into resonance and is observed by large amplitude of vibration. If the current is alternating, the force also alternates in direction and periodicity of this force is same as that of alternating current. Now, this condition is achieved when the frequency of the alternating current passing through the wire matches with the natural frequency of the wire. And the frequency of the alternating current can be obtained by the equation n equals to P by twice L into root T by M, where T is the tension on the wire, M is the mass per unit length of the wire, L resonating length of the vibrating wire, and P number of segments in which the wire vibrates, say 1 and 2 loops. Now, the velocity v of the transverse wave is given by the relation v equals to n lambda, where lambda is the wavelength, and for vibration in the fundamental mode, there is a single loop between the bridges of the sonometer wire. Thus, the length of the sonometer wire between the bridges, we got L equals to lambda upon 2, or we can write lambda equals to twice L. Now for P number of loops between the bridges, so the above relation we can write L equals to P into lambda upon 2, or lambda equals to twice L by P. Now the velocity of the transverse wave is V equals to twice n L whole divided by P. So from equation 1 and equation 3, first and the third equation, we can write the velocity of the transverse wave of the wire is V equals to root T by M. Thus for a particular wire with a fixed tension T applied, V remains constant, and for a fixed mass M, V square varies with T. So the mass per unit length of each material of the wire can be obtained from the slope of the graph, that is T versus V square. Now let's start the procedure how to perform the experiment. Now set up the electrical connections as follows. So this is step down transformer. So transformer we are going to join. We are going to connect the transformer at the two ends of the wire of this sonometer. So this wire we had considered, this is the constant one. So constant wire at the two ends we had joined the transformer. Now this is the weight box. So putting a suitable weight on the pan along with the hanger. So I had put it here 200 gram on the pan along with this hanger. Now switch on the transformer and placing the wire in the magnetic field. This constant wire we had chosen first, so this we place it in the magnetic field. Now the movable bridge slowly moved, and for a particular conditions of the bridge we got the violent resonant vibration and the amplitude is maximum. So this condition, amplitude, this is maximum here. Here you see that the where this is vibrating, so here the amplitude, this is maximum here. Now note down the resonating length of this vibrating wire. So we have to note down the resonating length from here. Scale it is attached here. So here we had got, this is 26.5 centimeter. So this is the observation table. So in the observation table here you see number of loops, tension applied, resonating length. So this is the first loop, first resonating length. So here we got the observation, this is 26.5 centimeter. Now tension applied. So in the tension applied you see the formula, this is capital M plus small m into G. Capital M, here this is mass on the pan. So mass on the pan we had applied here 200 gram. So this one, and small m, this is the mass of the pan. So mass of the pan including this hanger, this is measured here 53.20 gram. So this mass plus this mass into G, acceleration due to gravity, this is the tension here. So now here we have to find the velocity of this transverse wave, that is the first loop. So the formula, this is V equals to 2NL whole divided by P, and this is the frequency of vibration. SE means this is 50 Hz. L, this is a resonating length. This is for the first loop we have got here 26.5 divided by P. For the first loop P, this is 1. So put all the values, find the velocity here. Now for the same tension what we had applied here, for this tension we have to find out the second resonating length, that means second loop. So we have to find it here like that. Now here you see this is the second resonating length, that means second loop. This is the first loop, maximum vibration, no vibration, then again maximum vibration, that means antinode, node and antinode part. Now here the second resonating length we got here 46.3. So here 46.3, this is the second resonating length, that means for second loop. So again you have to find the velocity here, 2NL, V equals to 2NL whole divided by P. So here L, this is this much, 46.3, P, this is the second, that is 2, and N, this is the 50 Hz frequency of vibration. Now take the mean of these two here and square the velocity here. So for this tension T1 we got the velocity V square here, and the same process is to be repeated for two more tensions here for a particular material. And after that you have to apply the same procedure and readings are to be taken for brass and copper wire also. Now for finding the mass per unit length we have to plot the graph T versus V square, that is T along x-axis and V square along y-axis. So the nature of the graph, it is a straight line passing through the origin. After plotting this one, then you have to take any two arbitrary point, take the slope of this one, that slope value we got V square upon T. So that V square upon T, this is directly the mass per unit length of this material what we had taken here, constant n. And same process we have to apply for plotting the graph for other two wires, brass and constant n also, and find the mass per unit length of these two materials.